Just yesterday, my flight was delayed for 45 minutes because of a bug in newly released software. Or so they say, at least. Oops. Without discipline, releasing software can be a pretty risky process. We all know what this kind of looks like. Somebody has to check out the changes, they have to build them, and then they'll manually deploy them, and of course then we have to see if it works. And if something goes wrong in the process, we're finding out about it way too late. However, with discipline, it doesn't have to be this way. Continuous integration is a practice that can help. Continuous integration is typically the process of everybody merging and sharing their work frequently. It involves people frequently committing and sharing their work, and then everybody makes sure that the result builds, passes tests, and sometimes is packaged or is at least packageable. Of course, this is a practice. It doesn't have to involve any tools. It can just be people implementing these things. But imagine if you had a team member that was dedicated to this practice. That team member can be TeamCity. TeamCity, on every commit, as we'll see today, can allow you to make sure that your application builds, your tests pass, and the results get packaged. Of course, there's tons of benefits that come along with this. A few of the, what I like to refer to as secondary benefits. It can eliminate the works on my machine problem. It can increase the feedback. If something goes wrong, TeamCity can tell you about it. You're finding out about things when they happen instead of waiting until you're ready to release your software. It can help you fix issues faster. And when there are problems, since you're doing things more frequently, you'll have smaller conflicts to deal with. One of my favorites is it just helps build confidence in the process. If you know that there's a safety net behind the scenes, you're going to work hard to make sure that problems aren't introduced, but you'll know that something will help catch them if they do come up. Mistakes happen. You always have a documented process. So if you start automating the steps of doing this and allowing TeamCity to do it for you, you don't have to wonder about what is necessary to release your software. And of course, it allows you to release your software or deliver your software much faster. But as I said, these are secondary benefits. The things I think that we do this for, or the things I enjoy the most out of this, is it frees up our time to be innovative. If we don't have to manually do all this work, and then we don't have to deal with mistakes when they come up, we can be innovative in what we do. If we get fast feedback, we can experiment easily. It also improves communication. If you're working and sharing your code with other people much more frequently, you're more likely communicating better. And most of all, it's a proactive strategy to deal with problems instead of a reactive one. All right, so enough of that. Now I want to jump into how you can set up continuous integration with TeamCity. And the first thing I'm going to kind of walk through is what I like to call a commit step or a commit build. And the reason it's called that is because on every single commit, we'll set up TeamCity to build the application, if that's applicable in your environment, to test the result, and then package it. So let's hop over to TeamCity. Okay, actually first, I'm just going to walk through just briefly what I have set up. I have a simple application with some code and some tests, and it's a .NET project. Though along the way, I'm going to kind of point out where other tools may come in if you're working on other platforms. All right, and then let's hop over to TeamCity. Okay, so TeamCity has this concept of a build, as I just said before, and I'm going to create what we'll refer to as a commit build first. Builds are just essentially a set of steps that you can execute and have executed on an automatic basis to do some things and produce some results. And I know that's kind of vague, but we'll see some examples today and hopefully solidify that. Builds are organized into projects. TeamCity has a nice hierarchy of projects that you can use to organize them. For example, for today's demo, I have a demo project, and I have another build actually already set up, and we'll add more builds to this project as well. All right, so the first thing I want to do is create a commit build, and this is where we will set up steps to build, test, and package our application on every commit. Okay, so I'm going to hop over to the demo project. Oops, sorry. And I'm going to create a build configuration. And let's just call this commit. Okay, and then one of the new features I like about TeamCity 8.1 is that you can have it basically guess your repository settings by just giving it a URL. So you can go here and I can say, hey, go ahead and guess this for me, and I can hit create. And then let me grab the link here. If you've got a repository out on GitHub, you can look at it afterwards. I just have to paste that in. Oops. Maybe a little bit too much. There we go. Okay, and then I just hit the create button. Oh, and it actually detected I already have a VCS root, so we can just go ahead and use that. Another feature I like is that if you've already used a repository for another project, you can just reuse the same settings for another build as well. All right, so the next thing we need to do is we need to first set up a build step. So once everybody checks in the code, the first thing we'll do is build this. Now, this doesn't always apply to every environment. If you don't have an actual like compilation step, this step might not be applicable, but maybe you have something where you compress some elements or do some transformation of elements, and that would be similar. One of the nice new features of TeamCity 8.1 is that it has these automatically detected build steps. This is especially helpful with new people to the product. They don't have to necessarily know every single setting to set and tweak everything. They can kind of get in and experiment and learn about the tool without being overwhelmed with all the settings that they'll have to set up and to get things actually working. So the first two things it's detected is it says, hey, it looks like you've got a .NET project, and it's detected that I'm using NuGet, but I don't have packages checked in, so it's suggesting that I want to install packages as maybe a first step. So all I have to do is just actually say use this if that's what I want. You don't have to. There's just recommendations. It may not be what you actually want to use. What that's done is just create a build step for me. So instead of me actually having to go through and set a bunch of settings, it said, oh, it looks like you've got a solution file. And we'll go ahead and run the NuGet installer. And if we look at this, we'll restore packages when the build is first run. Okay, so let's go back. And then I want to add another build step as well. So if anybody else has dependencies, it's a simple way to pull them in so you don't have to store them in version control. And the next thing it's suggesting is that we should add a Visual Studio build step. So once I have my packages restored, then it will actually perform a MS build essentially. And I add that, and you can see that it's set a few things up. It detected that same project file, and it's using a rebuild target with a release configuration, which is pretty standard. You could go tweak this if you wanted to, but again, out of the box, it's a nice feature just to kind of experiment with the product and let it use some reasonable defaults. All right, so we've got a simple step here that will actually build our application. So before we go any further, let's go ahead and let's just run this. So I'm going to run this build, and it's running, and go over to the build log, and you can see it's run the installation, restoring of packages, sorry, and it's run the build. So not a lot there, but this is a good start of the process. So we know at this point that our application is building at least. Okay, but that's not too exciting. Let's add something so we can visualize what got built. So the next thing I can do is go back to the configuration settings, and I can identify what the artifacts of the project are. I'm going to copy this over. What this is, so once this project gets done building, it generates a set of output files essentially, and I can then go ahead and flag those as things that I want to keep as an artifact of this build. This is that packaging step I was talking about. And one of the nice new features of TeamCity 8, I believe it is you can use the little tree view to explore your project once you've built it for the first time. And you can go into, drill into, and pick the artifacts that you want to include. So in this case, this is a typical .NET project. If you're not familiar, the results of a release build go into bin/release. So I'm just going to say I want to keep that entire folder, and I'm going to actually just flatten it out to nothing. So I'm going to flatten it into a root directory, and that's my artifacts for the project. So let's actually see what this looks like, though. So I'm going to save that, and I'm going to run that again. And it's successful. And you can see here are the artifacts for the project. So let me hop back, actually. So here is the commit builds history, if you will. The first build there where we just built the project, and then the second build where I had identified the artifacts. Now there's this artifacts link where you can actually download the artifacts. So whatever your compilation process or transformation process may produce, you can then package these up essentially, and you can download them right from TeamCity, or you can use them for subsequent things in TeamCity, as we'll see today. So it's kind of like zipping up your artifacts and having them ready to deploy. Okay, and so then the other step that we're missing from this process I talked about was testing. So let's actually go back to the configuration settings, and let's go back to our build steps. And I'm just going to manually add this step at this point. And we go to add build step. And I have in-unit tests in this project. If you're using some other testing framework, there's usually some type of a runner that can help you with that, or a plugin that can help. And so I'm going to select an in-unit build step. So this is the manual process of setting up a build step, whereas before we had used the automatically detected build steps. Not a lot you have to do other than tell it where your assemblies are at. So I've got a test project set up, and the result of that, since we're doing a release build, is going to end up in the bin/release under the test folder, and it's going to be this test DLL. So that's going to get passed to in-unit, and in-unit's going to run the tests in that library. This is all I have to do, and then I can hit save. And it's added it there to the end of the process. So when this build runs now, the NuGet restore will occur, the project will be built, and then tests will be run. So we're getting pretty close to that initial picture I'd shown you in that initial slide. Oh, and then artifacts are packaged at the end, which is just a setting in the general settings. Okay, so let's go ahead and run this again. And I'm going to go back to the home page and look at what's going on here. And this time it should fail if I got everything reverted properly. Yay, it fails. So I've got tests are failing. I can drill in here to see what's going on. So one of the really nice features of TeamCity is the test reporting is just phenomenal. Right on the home page there, you know that it's a test failure, and you can drill in and start to see what test specifically was failing. There's also a test tab where you can get the same information. You can, as you have more tests, you'll be able to search them and filter them, etc. So I know this critical test is failing, and I can see why it's failing here. And then let's go ahead and fix it. But before we do that, excuse me, before we do that, I want to actually set up the last part of the process that I haven't got to, which is on every commit, we want to run this process. So I want to set up a trigger so I don't have to hit the run button every time I want this to happen. So we're not going to want someone to have to log in and hit run every time. So let's go back to the configuration settings, and let's go to triggers, and let's add a new trigger, and let's pick a VCS trigger. So what this is going to do is anytime somebody checks something in, it's going to kick off this process. You could tweak this if you want, but we're just going to leave it like that for now. There's also other triggers you could use if you wanted to schedule this, or we'll see later on today, link this to other builds. Okay, so let's go ahead and save this. All right, and then that's all we need to do to trigger it. Let's go over to our code, and if we look at the critical test, of course, I just have a nice little exception, and the best way to fix this is just delete the test code, right? Okay, and then I can go ahead and I will check this in. Let's just fix tests, and I will push this. Okay, so that's pushed, and let's hop back to the TeamCity interface and go to the main page. And I think I didn't set that up to run. It checks every 60 seconds. That was the default. I should have flipped that down to 1. So we'll just wait here for a second while that's waiting to detect the change. So the nice thing about adding tests to your process is it gives you the ability to guarantee some level of quality in what you build. So not only is a compilation or transformation step happening successfully, so people aren't checking out the code and saying, hey, the build is broken, all of your entire suite of tests can be run as well. Of course, people should probably be running the tests before they share their changes, but the reality is sometimes we have a lot of tests and sometimes we forget and make a mistake. So it's great to add this step to check the tests and find out when maybe there's a test we didn't know was related that was impacted by a change. So you can see pending has just shown up. So it pulls that repository at this point is how it's set up, and it detected that there's a change, and it's going to start, it's queued it, and it should start working on it here. This probably just needs to refresh the interface. There we go. And it's doing the same build process that we had just set up. And the tests are now passing. So this is a nice feature of this high-level overview of what's going on. You can easily see that there's 2 tests that are passing on this project. And if I go back to that commit build, I can see the entire history here. We can see there's the build with the failing tests, and now we have passing tests. So pretty simple. All right, that's all I've got for the commit build. I guess we could take some questions now if we have any before we move on to the next step. I don't know if we have any questions at this point.
Wes, I think right now Pavel is answering them. So if you want to continue, he'll hop in if there's something for you. Okay.
Sure. Just wanted to give a chance. Yeah. If you guys have questions as I'm going here, if something doesn't make sense, go ahead and shoot us a question, and I've got kind of some breaks laid out here where we can answer them. All right. So the first part of the continuous integration process is set up. Let me hop back to that. So we now, every time a commit happens, we build it. We build the result, we test it, and we package it. And TeamCity is going to do this for us automatically, so we don't have to actually verify that every time manually. Though, of course, if you're sharing your changes and you're merging your work before you push it back to everybody else, you probably want to do some of these similar things to make sure that TeamCity is just a fallback and is not who you're relying on to make sure these things work. Okay. The next cool thing is, after we've got these results packaged and we have some sense of quality or some sense of confidence that the result is something we want to share with people, maybe for testing purposes initially, maybe later on to actually deliver to a production environment, we can set up a process to take the built product, the artifacts that we packaged, and we can deliver them into an environment. This helps alleviate the problem of manually deploying things, only to find out that maybe we forgot a step, maybe we didn't update a configuration appropriately, or just the fact that it takes a lot of time to do this by hand. And of course, one of maybe the best parts is the whole entire process is documented in a script that if it doesn't work, it's going to get updated because it's the only process whereby you deliver things. So you're going to fix it when it breaks, versus that Word document that describes the process that nobody ever goes back to update. All right, so I am going to set up let's hop over. We're going to set up a new deliver build. And this is more in the world of continuous delivery, which is a natural extension of the same practices behind continuous integration. And we're going to hypothetically say we're going to deliver this packaged product into a testing environment. Okay, so I am going to go back to the home page. And so we have the commit. We have the commit build that we had set up before. And we can go ahead and we can create a new build configuration. And we can call this one deliver. And we don't actually need a VCS root to do this because we don't need to pull the changes. So I'm going to skip that step at this point. We're just going to grab the artifacts of the last step, and we're going to deploy those. So to do that, I'm going to jump to the Dependencies tab. And the first thing is I'm going to add a Snapshot dependency to the last project we set up. And what that's going to do is it's going to guarantee, well, in a second here when I set up the artifact dependencies, it's going to guarantee that when we say we want to release this build out of the commit build, a specific build number, as you saw before we had like numbers 1, 2, 3, 4, 5. When we want to release this specific one, that we'll actually grab the artifacts for that. So I'm going to add an artifact dependency as well. And I'm going to say build from the same chain. And I could change how this gets mapped, and I'm actually going to, how do I want to map this? I want to put everything into the build folder. So I'm just going to grab the artifacts from the last project, and I'm going to throw them into a build folder. Excuse me one second, I need to clear my book. Okay, I'm going to grab the artifacts of the last project, and I'm going to spit them out into a build folder. All right. And then let's go ahead and just, actually, no, that won't be easy to verify. Let's go ahead then and set up our a few extra things related to this. So the first thing I want to do is I'm going to hop back to the general settings. And instead of having this deliver build have its own incrementing counter every time something is released, I'm actually going to couple it back to the dependency, to the demo, to the demo commit, the demos project, the commit build number. So we're going to use the same build number out of the commit builds. So as our commit builds go 1, 2, 3, 4, 5, 6, 7, we may identify a particular build we want to release, and so we're going to name that. We're going to number that, the same between both our commit and deliver steps, so we know that those are in sync, if you will. Otherwise, we'd have separate numbers, and that might get confusing. All right, and then we can just save that. Okay, and then in this case, I'm actually going to be a little bit crazy here and show you that we can do other things in TeamCity besides just .NET stuff. I actually have a rake task to do the delivery process. So I'm going to go to build steps, and I'm going to add a build step in this case. So once this build kicks off, the artifacts from the last project are going to be copied into that build folder. And then I'm going to run a rake task that will take those and then deploy those into a hypothetical test environment. I'm going to turn off a few things I don't need. And I am actually going to show you how you can just dump content right into TeamCity instead of you can use a file, and it'll default to a rake file. But in this case, I'm going to copy some content in. And then I've got a rake task here called deliver, and it's not too complicated, and this isn't necessarily something you would use in a real environment, but essentially what it does is it uninstalls the service if it's already installed. So the project I had set up is actually a service, a Windows service project, and then it will remove the delivery directory, so it'll kind of blow away what was there already if there was something, and then it will copy out the build folder, which has the artifacts from the continuous integration process. So that's our packaged application. It'll copy that out to the delivery folder, and then it will install and start the service. Because just to make sure you believe that this actually works, I've got the localhost 9000 is the service will spin up a little website, essentially a little web server, and it will host just a hello world content. So I'm just going to refresh this to make sure this doesn't work. Fantastic. And then I'm going to come over here, and we're going to save this. Okay, so we have our rake step, and it's executing the deliver task that we had copied in there. Okay, and now let's go ahead and let's run this thing. And with any luck, this will actually work. Let's go back to the projects page. And it says it's successful. Yay, it works. So that's a pretty crude process, obviously, to just copy some stuff and install a service. But you can see that it starts to form a process whereby we can automatically deliver components into a testing environment in this case. But we're not done. So let's go ahead and have some fun with this. So obviously, we're going to have subsequent changes that we want to make to the project. So let's go back to the code, and let's go to the... Let's have it say hello world instead of hello. Okay, so this is akin to somebody else making some changes that you want to maybe deliver into a testing environment. So I'm going to save that, and then I'm going to go and I'm going to commit that and say hello world, and I'm going to push that. And so our commit build is going to fire, but we didn't set up any triggers for our deliver build, and that's okay. We'll get to that in a minute. And of course, I'm still waiting for 60 seconds. My bad. So while it's waiting to detect the change there, if there's anything let's go ahead and I'll just run it. I'm impatient. So I'm running the commit build here, not the deliver build. And it's passing through the test. So this is the process whereby I've made a change that I've shared with everybody. It's going to build, run tests, and package the result for us. And we can see the artifact still. And this is now build number 5. Deliver, though, the last build it ran was number 4. So right now, we still have the old version of the application running. At some point, though, we may decide that this build number 5 is ready to go into our testing environment. Now, with continuous deployment, you may just push stuff automatically into a testing environment. You may just push stuff automatically into a production environment. But that can cause problems. Without a lot of supporting infrastructure, sometimes it's a little bit too much work for it to be valuable. Instead, if we just take out the automatic trigger of the delivery process and make that manual, we can still get all the same benefits without the hassle of or the concern of what could go wrong if things are just automatic fully throughout the entire process. So what I can do is I can go to this commit build and I can say, look in the history page here, I can go to an action. Oops, sorry, go back to the main page. I have completely forgot what I must have missed a step. Well, okay, the other way I can do this is I can just actually run the deliver build as well. I was going to show there's actually a promote option. I just forget where it's at inside the commit build. I'll have to figure it out because I'm going to show that in a minute too. But so we've run the deliver build now, and I can go back to the website, and it now says hello world. So it's updated the application. So pretty cool. So this is a process whereby we can set up a continuous integration process to automatically check our code. And when we have a result that is successful and we are ready to deliver it to an environment, we can then manually trigger an automatic process to deliver it to that environment. Okay. And there's a couple of extra features that come along with doing this. Inside the deliver process, since we've chained it essentially to the commit build, we can go to the build chains tab and we can see kind of a history of what has happened here. So the first time we ran this, it took the 4th version of our application and deployed it. Number 4 there as well. The second time it took the 5th version and deployed it. So kind of a cool little way we can see a history of our releases, if you will. If we go to the settings for the delivery project and we actually go to the version control settings, excuse me, we can actually show changes from Snapshot dependencies as well. So it's a little option. This is a new feature, I believe, TeamCity 8 or 8.1. And we can see the changes then as well. So if I go back to the deliver build, let's go back here. Sorry, homepage, go to deliver, go to the history here, and take any of our releases. I guess this is only one with a change in it. And I go to the changes tab. So not only did this hello world impact the built product for the commit build, I can see it actually as what was delivered as well. So I can link that and see that hello world was what was released here. And if we had a whole set of changes from our repository, we would see those as well. All right. Any questions so far?
Okay, so there is a question about custom checkout directory. Is it possible to configure TeamCity to check out source code to a specific folder on the agent?
To copy a specific folder?
To check out source code into a specific folder on the agent.
Oh yeah, absolutely. You can configure the agent and override the setting where that goes. So usually you want all of that to be automatic. I guess sometimes I've seen that happen when oops, I think I made a bump something. I've seen that happen when you've got some dependencies to something else on that system that need to know where that is at. Yeah, but otherwise you usually want that to be automatic because it's kind of almost like an indication that maybe there's a little bit too much coupling between your test environment and the build of your code. But that could, yeah, I could see that being a necessity.
Yeah, actually, it's I would like to add that actually it's a good thing to have a build independent of exact checkout directory, and also TeamCity tries to reuse checkout directories among build configurations with the same version control settings, and this reduces the disk space requirements on the agents. So there was also one more question about deployment. How would you roll back a deploy that failed or had issues?
Yeah, sure. So my example here may not be so thorough to contain the components necessary to do that. But one thing you can actually do, and that's where I need to actually go back to the commit project, and I'm going to go into an actual builder. So build 5 is the one we have. There it is. I don't know why I must not have seen that before. Maybe I was blind. So let's say that I have build 5 out right now, and this is great because this is what I want to talk about. We want to go back to version 4. Now this is just the code. There could be database changes and other implications as well. But if we wanted to just roll back the code in this example, I can go into build number 4 here, and I can just go to the actions, and I can say, hey, promote this build. And I could have this chained to many different things. So the delivery step I have set up right now is hypothetically a delivery to a test environment. If I had other environments, I might want to pick where I promote it to. But in this case, I just have one. So let's go ahead and run that. So this is essentially the start of what you would do to roll back. Now, if you had everything, built into this process to actually deliver the appropriate things into that environment, you could do an entire automatic rollback as well. There may be some considerations if you haven't yet maybe automated your database migrations, for example. And if I come back over here, you can see it's running hello now instead of hello world. And that's essentially how you can roll back. And you can just keep going back and forth. We can go into build number. You can see the history here of the deliver build as well. It went from 4 to 5 to 4. If I go to that build chains tab, you can see when all of this stuff happened. So you have a nice audit of this. So I went from 4 to 5 to 4. And we can even go back into number 5 when we're ready for it to go back out if we're ready to test it again, and we can promote it as well and push back to version 5 then. And so that's why it was critical to use a snapshot dependency, so we are actually promoting a specific build and not like the last successful build. Come back here, and we're now back to hello world. That's where that manual step is really nice in this process. When you split this up so that you have a commit continuous integration build and a deliver build after it, then you can kind of like have a history of your application, if you will. And on demand, you can deploy any version of that application into any environment, theoretically. Any other questions so far?
Okay, here's another question. How to deploy result artifact to some application server?
Oh,
seems how it depends on application server. Yeah. How to deploy result artifact to some application server?
Oh, sure. So, I mean, I have my little test script here, and it's just deploying to my local machine on, but it's actually installing it as a service and everything. So it's the whole entire process. So the only difference would be is if you were to push that to another server instead. The delivery process itself, or how you deliver, is where a lot of other tools can come into play as well. Some people All right, any more questions?
Yeah, I think we can process other questions a bit later.
All right, the last thing I wanted to go over, since we've got a little extra time here, I have another build already set up so that we can just kind of walk through what this is. I'm going to hop back to the slides here. So sometimes we don't have a process that we can start at the beginning to get the benefits from TeamCity. Maybe there's some step in our process that is expensive, if you will. It takes time, or it's a lot of manual work, or we've got a lot of errors that would be detected by maybe doing that process a little more routinely. And so we don't have to actually set up a build, a test, a package, a deliver step. That's not the first approach we can come from. We could actually say, hey, you know what, our functional tests take a long time to run, and it's a lot of work to manually trigger them. Or maybe in this case, we have some inspections that we would like to improve the quality of our code, but nobody ever runs the inspections, nobody ever looks at the results. So could we set something up that would actually look at this for us on some routine basis? Maybe not on every commit, but maybe once a day, once a week, and have some results ready for us, or have it tell us actually when there's a problem, instead of us having to remember to do something that we may not get to otherwise. So that's where we can actually just say, hey, in our delivery process, this step is where the pain is at right now. Let's tackle that, and then the time we save there, we can then invest in the rest of that delivery process. So let's hop over to TeamCity, and I've got a WebStorm inspection sample set up. So this is not just .NET stuff. It can be any platform. And if I hop over to WebStorm, one of the nice things about inspections, and especially about using WebStorm or ReSharper on the .NET side of things, is you can define as a team the rules you want. You can share those through your version control system with the rest of your team, and they'll be enforced for you right within the IDE. So right out of the gate, all of your developers are working on the same set of rules, and as they're developing, WebStorm or ReSharper or whatever the JetBrains product is can help tell you that there's a problem while you're working on it, so you can fix it right then and there instead of waiting for inspections to happen days or weeks later. So that's actually the best place to start with inspections, but we'll see in a minute we can then plug that into our continuous integration process as well. So I've got a quick little JavaScript sample set up here where I've got a violation of a rule. I've got a variable assigned to itself. Essentially, I've defined a set of rules that I can check within WebStorm, and I'm not going to go through all of that today, but in the project settings, you can set up scopes of things to check. And I've got a sample set up already that I'm going to just check that test file I had over in the other screen. And you can add whatever files or whatever you want to a scope. If this is helpful when you want to focus on maybe JavaScript versus CSS, or you want to focus on your JavaScript versus external libraries you bring in. So set up a scope, and then I can set up inspections. So I can work with my team of people to say, hey, what is it that we want to enforce as far as code rules, essentially? And in this case, I've only turned on a set of JavaScript inspections, so you can see there are tons of other ones. And we can go through these rules and decide what fits best for us. And then we'll get that information right within the IDE when there's a problem. But you know, the reality is sometimes we have legacy code and we have a new set of rules we've established. Sometimes we just get busy and we miss something. So sometimes it's nice to actually have somebody else checking this stuff for us on some type of routine basis. And that's where we can plug all of this in to TeamCity. So with those things set up within WebStorm, then I can hop back over to TeamCity. I'm just going to walk through what this configuration looks like. I'm not going to actually set it up because it's a few extra steps, but I have a build step here where I say, hey, use inspections from IntelliJ. And this will work with many of JetBrains products. And if you're on the .NET side, there's an inspections for .NET. And that's all the build step is. So that's all this build process does, is it just runs a set of inspections. And then the only thing I really have to do is I'm pointing it at the profile that I had set up within WebStorm, so that TeamCity is using the same set of rules that the team is using. and that's really all I have to do at this point. All right, and then let's hop back and let's go ahead and run this, though I've already run it, so it won't be as exciting. Oops, let's go back to the projects. can see we already have a successful build here from before. And you can see that we don't have any errors, but we do have a problem. We can view the inspection report. And you can see the exact same error message, or sorry, warning, I guess, if you will, is coming up here that was coming up within the WebStorm IDE. So it's just a nice way to have TeamCity, again, providing a safety net for people. So if we forget these things, we can find out about it. And then what you do with inspections can kind of take off from there. People will actually hook these into continuous integration processes, maybe once a day or less frequently than probably on every commit, because these can take some time to run. But then they can do things like, maybe you inherited a legacy code base with 500 issues. You can't fix all of those issues, but maybe what you want to do is say, hey, I don't want it to get above 550 or 525. I don't want it to grow very much. So you can actually set up the build process to fail if they grow beyond some number that's whatever is deemed reasonable. So that way you're at least not getting more problems building up. And maybe over time you want to pull that number back as you have time. You can work on those inspections and pull that number maybe to 475 and 450 and eventually bring some consistency to the code itself. All right, does anybody else have any questions?
So there's a question about code signing. How do you handle code signing? Configure it in Visual Studio or make it a build-only process?
That's going to be pretty team specific. Well, the reality is that continuous integration is a practice. It's very generic, and you kind of have to decide how it fits within your existing processes. So in the case of code signing, if that's part of the steps involved in producing your application, what I recommend you do is sit down and kind of at least write out how the process is existing. If you have any scripts that are involved, look at those and kind of get an idea of what things look like right now, and use that as a map as you implement a continuous integration process, and with the goal in mind of automating every single one of those steps. Now, whether you automate that inside of TeamCity with build steps, or maybe you use an external build tool like MS Build or Rake, that's kind of a decision you have to make yourself as to where that fits in your development process and what gives you the biggest bang for the buck. And that's where you can decide then, do I want the code signing to be part of something I set up in Visual Studio, or do I want to make that external to the application? So maybe that's not a hassle on developers that are working on the application. It's only a concern of packaging the code, if you will.
Okay, here are two more questions related to previous part of the demo. The first one, can you elaborate on snapshot versus artifact dependencies use cases?
Yeah,
and another one is related. Can you show us an example of a build pipeline? Actually,
yeah, we kind of did.
Okay.
Let's hit on this again. So let me do the build pipeline, because that one's the easier one to visualize. So by setting up dependencies between builds, you can start to form a set of what is in TeamCity it's called a build chain. And your build pipeline, I guess it really depends on what you're looking at. We saw that first slide where we were talking about. Let's go back one here, where we were talking about continuous integration just being this piece where when people share their changes, the code is built or the application is built and it's tested and it's packaged. And in this case, then we added a delivery step. So this is what I would kind of see as the beginning of your build pipeline, if you will. Now, whether or not you compose that with separate builds in TeamCity really depends on your project, though most people do split things apart because you don't want to necessarily deliver every single time somebody makes a change. There's a lot of problems that can come along with that. That said, if you have a really small project, or maybe you're just kind of spiking on something, maybe you do want to deliver on every single build, so you could put it all together in one build within But then the nice thing is, like we demonstrated, is you can split things out into separate build builds, and you can trigger them separately. So whereas the commit step actually triggers every single time somebody is changing and sharing their changes, the deliver step is something that's manually triggered. So it's something that somebody decides not only have all the automatic tests passed, but maybe we've done some other validations to know we're ready to move it into a test environment. Maybe that's as simple as we've got a build ready in the commit stage, but we haven't talked with any of the external testing resources we have, maybe within the business or otherwise, and we need to let them know we're going to roll out a new version of it before we go do that. So then that's the nice thing about splitting this out, and you can actually get a build chain to start looking like your build pipeline, actually. And you can add more steps to this, too. So maybe this is actually not deliver, but it's deliver testing, and maybe you have deliver production. Maybe you have an inspections build as well that doesn't happen on every single commit, but maybe it happens on some routine basis, maybe once a day or something like that. And then any successful result out of the inspections then is a candidate to be promoted to a testing environment or eventually a production environment. On the artifacts versus snapshot dependency, let's go back into the deliver, and let's go to the settings on that, and let's go to the dependencies. Okay, so artifact dependencies is just, I want to grab, and let me pull this up actually and edit this and show the options. Artifact dependency is I just want to grab the results of another build. It doesn't necessarily tie to a specific version of the application. It's just I want to grab some results from a previous build. And you can see that you could do things like the last successful build. So every single time if I had done that instead of from the same build chain, then every time I ran the deliver step, it would just be the last successful build. It wouldn't necessarily be build number 4 or 5 or 6 or whatever. It's just going to be the last successful one. You can do the last pin build. You could do the last finish build. So that doesn't mean it was successful. It just finished. And there's other options as well. And in the case of the demonstration I did, I chose build from the same chain. So that way I know that if I am promoting version 4 of the application from the commit build, I'm delivering version 4 then. If I'm promoting 5, I'm delivering 5. So but an artifact dependency doesn't trigger that same version. That's where you need a snapshot dependency. So you're actually linking back to the same version of things in the previous build. And then if you actually check out the code as well, so in the version control, I didn't actually attach any version control to this project, or sorry, to this build. If I had, the version that I get from version control would be the same as the version from the prior step. And so that's useful if maybe you are working with a language like a scripted language where there's really no build step. Maybe you're dealing with PHP or Ruby or something where you just need to copy some files. And so you can, in your deliver step, then link to the same version, get the same files. You don't have to necessarily package all those files up as an artifact then. You can just go ahead and copy all of the contents from the repository, and you'll know that it's the exact same version as what passed all your tests in the previous commit build.
Okay, I just wanted to add that
yeah.
One of the most frequent uses of the snapshot dependencies is the ability to take one single monolith build and break it down on different parts, and then combine these parts with snapshot dependencies in a build chain. And in this case, you can actually improve the performance of the building, because all those parts can be executed on different agents at the same time, and all of the parts will take the same revision, and so they will be consistent. For example, if your build runs several thousand tests, you can split it on different parts and run different parts of tests, but eventually all of them will be started on the same revision, and they will be consistent. So that's the main feature of snapshot dependencies. They provide consistency among different builds combined in a build chain. So there's a There's one more question about .NET assembly version increment. So how do you handle .NET assembly version increment? Does TeamCity support it out of the box?
I'm sorry, I'm not certain I understand the question.
I guess it's probably about
assembly version.
Automatic assembly version patching.
Oh, okay.
Yeah, I think it's about.
So what you can do, and I guess I didn't actually demonstrate where this would fit in, is you can do any number of things to tie different numbers into your assembly version. Perhaps you would like the assembly versions to match your build numbers. If that's the case, the build number is an environment variable actually that you can make accessible to the build process and inject it into your basically your assembly version. So you could do that. So then like I said, I've got version 4 of my build here. If I wanted that to maybe be 1.0.4, I could pass that 4 into the process of actually building the assemblies, so that it can actually pick that up, or the assembly version matches the builds in TeamCity. That's just one hypothetical way. Another thing I've seen is sometimes, I'm trying to think, well, that's kind of separate. Sometimes you want to embed some other information in your project. But yeah, you can grab all kinds of stuff from environment variables and inject it into your build process as well. So we go back to, let's go back to the commit stage and go to the build steps. And I guess if I added a step here, I could echo out the environment variables, but yeah, trying to see if there's anything. I mean, you can pass all kinds of stuff here too. So you can pass other parameters as well to the build process. You pass them to MS Build and they can be passed along. So you can pass properties along to the build process as well. Yeah, and I think if you want to kind of play around with and see what's available, there's these nice little auto-completes that you can scroll through and type through. That was how I grabbed that build number before. Build number would be one of those parameters you could use. All right, any other questions?
Okay. So there is a question about custom report. Do you have an example of some custom report presentation in TeamCity?
Custom what?
Custom report, probably some HTML report or something.
Oh, custom report. Yeah.
Yeah, custom report.
Actually, so. I actually have one. Yeah. So yeah, your build process could generate. I'm trying to remember where I put this. Your build process could generate any number of things. For example, if you're using Independ to generate some reporting, you can actually then get that to show up as a part of your build process. So let's go back to the projects, and I'm going to add in the. Oh, looks like it's already out there. I forgot where did I put that thing? Sorry. Let's go back to. There we go. Okay, and I'm going to go to the history on this one. And let's go to this one. So in this case, I actually added a tab to the process for Independ, and it can load the HTML report for that as well. So there's several different ways you can do this, but you essentially set up a report and flag it to be copied out of the results of the build process. So inside of this build, I have a build step that runs Independ, right? And then that's going to generate a report. I think I've got it in here somewhere. Yeah, I don't know exactly what I named that one that time, but then I can go pick up that report and add it to a report tab. So I've got a report tab defined here. I've added an element for Independ, and I'm just pulling the Independ report.html right out of the results of the build. And then by doing that and giving it a title, say I could change the title if I wanted, Independ 2. And then I can go back to, oh yeah, where did I put the, I need to show that thing. That's weird. Oh, you know what I've got? Show them. I wonder if I hit it some other way on myself. Let's go back here, and let's go back to Independ, and go back to a successful build. You see Independ 2 now shows up. So all that is just grabbing an HTML report and embedding it as a tab inside of a specific build's output. If it doesn't show up, it's not going to have the tab then, obviously. If it does show up, the tab will be there.
Okay, so here is a question about Java and Maven. How easy is it to switch between versions of Java or versions of Maven?
I am not an expert at this, but what I'll do is I will go to my demos and let's go create a build configuration so we can look at this really quick. And build steps. And I imagine this is probably linked into a particular version of Java, but you can change like in a lot of things that use Java, there'll be an option to change what version of the JDK you're referring to. And out of the box, TeamCity's picked up the one I have installed on my machine, but you can add others as well, and then you can specify those specifically. Yep. You might even somehow make it as some type of parameter if you needed to build something against multiple versions of Java. You could actually use a build parameter and run the same build maybe multiple times, but for different versions of Java.
Yeah.
It kind of depends on your particular situation. But go ahead. I'm not an expert at the Java side of things, so if you want to chime in.
Yeah, I just wanted to add about Maven. So, Wes, could you please open the Maven build step?
Yeah. Oops.
So TeamCity actually comes with.
Do you need the advanced option?
With a few versions of Maven out of the box. If you open Maven selection, there are several versions of Maven. Or as always, you can use custom Maven if you want. You will need to install Maven on the agent in this case.
It looks like there's some Java, the JDK versions as well.
Okay, so I think that's it with questions. Oh, here's one more question about branch. If I need to create a hotfix branch on one project of the hierarchy, is there a way to clone the flow dependency chain and change the branch on that one project? Well, actually, the dependency chain is placed inside the project, inside some projects, so you can actually clone the project itself and change the branch in the project copy. We usually recommend to use a parameter instead of a specific branch. So we usually recommend to use some %branch % in places where exact branch name is required. In this case, when you copy a project, you can just change this parameter, and you don't have to go through all the build configurations and change there. Okay, another question is about agent installation. Is the agent install a manual process?
It really depends on how you want to do that. There is an installation that you can run on machines. If you're using like agents in the cloud or something, there's actually features that can help you provision agents in the cloud automatically. It really kind of depends on your setup. So, but there is actually a manual installation, just an MSI. It's just a few clicks through to install the agent. I believe you can download that from somewhere in here too. Yeah, you can install build agents. It looks like you can launch them as well from the browser. I usually install them, so.
Oh, I think we answered all the questions.
Yeah, so thank you everyone for joining us today. For more information regarding TeamCity, you can visit the JetBrains website for TeamCity, jetbrains.com/TeamCity. Also feel free to visit our blog for future posts. You'll see the link there. For future, well, to view this recording and any past webinars that we've offered, plus any videos made on TeamCity and our other JetBrains products, you can visit us on YouTube at JetBrains TV. For feedback regarding this session, feel free to send a tweet to Wes. You see his Twitter tag there, or you can send him an email, wes@fullcitytechnology.com. If you're interested in any consulting for implementing TeamCity, you can visit Wes's website there, fullcitytechnology.com/TeamCity. Thank you so much for joining us today. For more information on TeamCity tips, product tips, and also to register for any upcoming webinars we hope to offer more in the future on TeamCity, feel free to follow TeamCity on Twitter @TeamCity. Thank you so much. Have a good rest of your day.